Okay, so this last little section that we're looking at is where you're going to add and subtract functions. So before adding or subtracting functions, you have to evaluate the functions beforehand. So we have to go through and evaluate first, and then we're going to add and subtract. And we talked about evaluating both in the Zoom and in some notes at the beginning of this when we solve functions. So we're going to use function f. So function f is negative 10. So negative 10, so this would be 2 times negative 10 minus 5. 2 times negative 10 ends up being negative 20 minus 5, and that ends up being negative 25. So then I do this again, and this time I'm going to use function g. So g of 10, so I'm plugging in 10, you get 10 squared minus 3. So 100 minus 3, because 10 times 10 is 100, ends up being 97. So then when you go through and you do this, you're going to say function f of negative 10. So you have negative 25. And then you're going to add that g, so plus 97, because you're adding that. So negative 25 plus 97 ends up being, so that ends up being 72. So this will end up being 72. That's your answer. So that's when you're adding. So when you're subtracting, we're going to go through and we're going to do the same thing. Notice I have g first. So g of 8, this is going to be 8 squared minus 3. So that's 64 minus 3, which is 61. And then my f, so f of 3, that's going to be 2 times 3 minus 5. 2 times 3 is 6 minus 5 ends up being 1. So you're going to take 61, because that was first. The g is first. So 61, and then minus 1. And you end up getting 60. So that's for adding and subtracting. Not too bad. The next one is multiplying and dividing. We're going to go through. This time our functions changed, so it's not the same function rules. Our functions changed a little bit. And again, you're going to do that same process. So we have g. So 3 times 8 plus 1, because I'm substituting 8 in for function g. So 3 times 8 is 24. So 3 times 8, and then you're going to go, so 24 plus 1 is 25. And then you're going to do this for function f. So function f is going to be 4 times 2 minus 5. So 4 times 2 is 8 minus 5. So 8 minus 5 ends up being 3. So 8 minus 5 is 3. So now here's the part that you're going to take function g. So you're going to have that 25. And now you're going to divide that by function f, which is 3. And you can leave it like that, or you can go through and you can make it into a decimal. So 25 over 3, or you can make that into a decimal, which is 8.3 repeating. Either one of those two are totally fine. So again, we're going to have function f, and I just made my function the blue ones. So function f, that's 4. So I have to evaluate that. 4 times 4 minus 5. So 16 minus 5 ends up being 11. And then my function g, so g of negative 3. So this time, g of negative 3, this is where you're going to plug this in. You're going to have 3 times negative 3 plus 1. 3 times 3 is 9. And a positive times a negative is a negative. And you get negative 8. So so this is multiplying. So this one is multiplying. We're going to take our function f, and we're going to multiply it by function g. And that's negative 8. So 11 times negative 8 ends up being negative 88. And that's your answer. So this is how you're going to add, subtract, multiply, and divide functions. And what you have to do is you're going to go through and you're going to evaluate first. Okay, so now we're going to talk about what it means to actually go through and do a composite function. So a composite is way different. Okay, so composite functions are going to be a little bit different here. And this is where you are going to go through and you're going to look at this and you're going to work, and this depends on another function. So composite functions is a function that depends on another function. So it's a function that depends on another function, and that's recreated when one function is substituted into another. And I like to think of this as working inside out. So f of g of x is the composite function is formed when g of x is substituted in for f of x. Now I'll explain this in just a second. But this is, or f of g of x is read as f of g of x, and then we're going to work from our inside out. So you've got these two functions over here. And when you're looking at a graph, so if f of x and g of x are going to be these two functions that are graphed over here, what's the domain of g of x? So when you're looking at the domain, you have to find the domain. So first, we're going to look at the domain. And remember that, and this says that I'm going to look at function g. So here's my function g, and the domain is that x value. So my domain goes from 2 to 5. So this goes from 2 to 5. That's my domain of function g. And then it asks you to find the range of function g. So my range, remember we had to do this before, is going to be on the y-axis. So my range goes from 1 all the way up to 5. That's my range. So now, then we're going to look at the domain of function f. So the domain of function f goes from -1 and to 2. So this stuff wasn't that bad. This is all kind of a little review. But to answer this question, this is where it gets to step 4. So it says, is there anything similar to the domain of f of x and the range? So we're going to look. So basically what this question is there anything similar to the domain of f of x and the range of g of x? So I'm going to look at these two things. So this range and that domain. So if we look, okay, so these numbers, and I'm just going to kind of put out our numbers. I'm going to go from 1, I'm going to draw a number line because it actually helps me out. And this is 0. This is -1, 1, 2, 3, 4, and 5. So if I just kind of do a number line, and then I'm going to color, and I color coded it. So this goes from 1, the domain of f of x goes from 1 to 2. And I color code. And then right above it is I'm going to do the range. I'm going to look at my range. So this goes from 1 all the way out to 5. And what they're looking for is the similar. What is exactly similar to these things? So the only part that's similar is going to be from 1 to 2, because that's where they both have something. That's what the similarity is. Because this is similar, so now my similarity parts is basically, so the composite, the domain of that composite is going to go from 1, this is asking for the domain, so that's an x, to 2, because that is the similar part of the range of g of x and the domain of f of x. So basically, that's where they're going to be similar. And basically, and then we're going to go over how come that actually really works, and we're going to talk about that. and then X part. So this is where you're going to have, this is the composite, this is going to try to figure out. So basically what happens, if you have, you're working from your inside out. So we're going to look at our g of x. So I had to find my domain, and then I spit out my range. Well, that's now going to be the x value of function f. That's now going to be my x value of function f. This is why I look at the range of g of x. And now the only part that is the overlap is going to go, that domain of this is just where they're going to be the same. Where do they go? From 1 to 2. That's the only part that's going to be the overlap where they're going to be exactly the same. And let's go through another example that's not a graph. And hopefully you can kind of get this. And remember that in the Zoom, we'll go over these things because this can be kind of difficult. So what I'm doing is I'm plugging in my equations here. So I'm going to have 3/4 times -2 minus 3, and then I get my answer. So 3/4, so 0.75 times -2 minus 3, and I get -4.5. So again, 3/4 times 0 minus 3 ends up being -3. And then 3/4 times 2 minus 3. So 0.75 times 2 minus 3 ends up being -1.5. Then I'm going to have 3/4 times 4 minus 3, and I get 0. Because 3/4 of 4 is 3 minus 3. So 3 minus 3 is 0. 3/4 times 6 minus 3. And that's 1.5. And then the next one, 3/4 of 8 minus 3 equals 3. So now you've got this. So now here's the part. These values right here, because we're going to plug in function f, so all of these values, this ends up being the x value because I plugged 2 in, -2 in. So this is now going to be my x value for function g. So -4.5 is my x, and this will be -3, -1.5. Notice these are the same numbers. This is 1.5, and this is 3. So these are exactly the same numbers. So now what happens is now I'm going to plug those in. So I'm going to do the absolute value of -4.5. And then the absolute value of -4.5 is positive 4.5, or just 4.5. The absolute value of -3 is 3. The absolute value of -1.5 is 1.5. The absolute value of 0 is 0. The absolute value of 1 is 1.5. And then the absolute value of 3 is 3. So then what happens here, so these are all of your little numbers. And then what happens is this part, the answers here, these are just going to be your answers. So when I plug -2 in for f, and then I plugged it into for function g, so we start with the inside, you plug it in for f, and then you go back to function g, then I end up getting, so when this is -2, my answer was 4.5. When this was 0, my answer was 3. When I'm at 2, my answer is 1.5. When I'm at 4, my answer is 0. When I'm at 6, my answer is 1.5. And when I'm at 8, my answer is 3. So this is going to be, that's going to be if you're going to have a table. The next one is we're going to do function notation. So we work from the inside out. So we start with function g. So step 1 is you start with function g, f hangs out and waits his turn. So g of 2 is equal to 3 times 2 squared. So 2 times 2 is 4. So 3 times 4 ends up being 12. So that's step 1. Step 2 is now I've plugged in 12. Now I'm going to substitute that in. So now g of 2 is really 12. So f of 12 equals what? Well, we know how to do that because we've done that in the solving. So we're going to go 12 plus 5 ends up being 17. So that's going to be my answer right there. That's going to be my answer. So my answer is 17. Okay? So now let's look at this. Actually, I'm going to do C first, and then I'm going to go back to B and D. Because, well, yeah, I'm going to do C first, then I'm going to go back. So step 1, we do f of 2. So f of 2. So I plug in 2 in for x. So 2 plus 5. And 2 plus 5 is 7. So step 2. So f of 2 equals 7. So now what happens is I'm plugging 7 in right there because that number right there is 7. So now I have g of 7. And g of 7 is going to plug. So I'm going to plug that in. And I'm going to go 3 times 7 squared. So this is 3. And 7 times 7 is 49. So 3 times 49 equals 147. All right. So let's look at this one. G of x. So I'm just going to rewrite this. So f and g of x, I'm just going to type all of this in because that's g of x. 3x squared. This part right here, I'm going to kind of do this. G of x is just that. So 3x squared. So now what I do is wherever I see an x in my function, so this would be 3x squared because this is now all x. And my function, that says x, then plus 5. And that's as simple as I can go. So that's my answer. 3x squared plus 5. So this time, we're taking this part right here, and I'm substituting in that function f. So g waits his little turn, and I'm going to substitute in that x, so f5. So x plus 5, and then you go through, and we're going to substitute that in. So wherever I have an x, I'm going to substitute in x plus 5. X plus 5, and then I square that. You can leave it like this because you may or may not remember from Algebra 1, but when you square a binomial, this is called a binomial, so it's because there's two terms. So this would be x plus 5 times x plus 5. So x plus 5 times x plus 5, when you go through and you multiply that out, you've got to multiply the whole thing. And this is what I'm saying. You can leave it like this, or you can actually multiply it out. You don't have to. Because there's two of these, and I call this length times width. Length, width. Okay, so this is x squared. X times 5 is 5x. This is what we're going to do next trimester. And then 5 times x is 5x, and 5 times 5 is 25. Combine your like terms. So this would be 3x squared plus 10x plus 25. So you can have that, or you can go one more step farther and you distribute the 3. So 3x squared plus 30x plus 75. So it's either one of these 3, but I would, if I were you, for A, distance learning, I would just leave it in the part that I boxed, and that's fine. Now, as you can tell, the order that you do things matters because these 4 things, these 2 things are not the same, and these 2 things are not the same answer. So the order that you do things kind of matters. So step 3, or example 2, sorry. So example 2, we're going to have f of 4. So I'm just going to substitute in f of 4, and we're going to find that. So f of 4 is going to be 3 plus 4 plus 5. 4 plus 5 is 9, just using our PEMDAS rules. The square root of 9 is 3 plus 3, or 3 minus 3. So this would be 6 or 0. And because we're only going to do, it's a function of a square root, you're not going to have the negative. So it's just that. It's just going to be 6. This would be 6. And you use your friend Desmos. Remember, you can still use your friend Desmos to double check that you did all these correctly. And because square root functions are kind of funny, so all I did was go 3 plus, and then you have square root, and then x plus 5. And then I get this, and then you want to find, the question is asking, when does this equal 4? So if I kind of go out here, and I'm just going to make this x equals 4. And I look, my answer is going to be 6. 4, 6, and it only hits at one place. So that's all I'm doing, is I'm just checking on Desmos. And that this is why it doesn't work, because it's a square root and it's a function. And we'll get more in depth in that. So this one, g of 4. So f waits its turn. I'm going to plug 4 in for g. So I use function g. So I have 2 plus 4 minus 1. Square that. So 4 minus 1 is 3. And then I'm going to square that. Plus 2. So f is still waiting his turn. So 3 times 3 is 9 plus 2. And 9 plus 2 is 11. So f of 11 now, we're going to plug 11 in for x for function g, for a function f. G equals 11 plus 5 is 16. Oops, that should be a plus, not an equals. Square root of 16. So the square root of 16 is going to be 3 plus 4. We're only going to look at the positive version. So 3 plus 4 is 7. And there's my answer. Again, you can check it on Desmos. Function g, substitute it in. You get 2. And then we're going to have negative 1 minus 1 squared. So you have 2. And then you're going to have times, and then that's negative 2 squared. 2 times 2 is 4. A negative times a negative is a positive. Times 2. So 2 times 4 ends up being 8. So g of negative 1 equals 8. When x is negative 1, that will be 8. Okay, we're going to substitute in negative 1 in for f first. So now we're going to have g waits his turn. Now we're going to have 3 plus the square root, negative 1 plus 5. Negative 1 plus 5. So negative 1 plus 5 ends up being 4. Because negative 1 plus 5 is 4. And then all I did was just copy this stuff down. I still brought down my 3. I still have the square root. The square root of 4 is 2. And I'm only looking at the positive version because it's a square root function. I'm not going to look at the negative because then that wouldn't be a function. And now I have 3 plus 2 ends up being g of 5. So now we're going to go through and we're going to put 5 into our function. So now we've got g of 5 is going to equal 2 plus 5 minus 1 squared. 5 minus 1 is 4. I'm going to square that. And 4 times 4 is 16 plus 2 ends up being 18. So G of F of -1 ends up being 18. So this is for you. This question is, hey, is this true or false? Are those exactly the same, or does the order matter? This is your opinion. You kind of put it in your own words because these are your notes.